Sorry about that. I think the card ran out, and also I'm on sloping ground. But what I can do is take some of this so-called copper 1 chloride, and just pour it off into here, and leave the remainder of the salt. Just cover just enough. I'll leave the, so I put that in there, and I'll put that one in there. Now we get this, and we get our gay carb. Our so-called gay carb here, our sodium bicarbonate, and we try this. We might get a bit of a surprise. I don't know. It's got a lot of salt in here, so we are actually getting fizz now. So that's acidic enough to actually get rid of the carbon dioxide from the bicarbonate, and I assume therefore the carbonate. So if you have a salty environment that has copper in it, it will be acidic enough, there will be patches or places, areas that will be acidic enough to actually get rid of the carbonate. So they either put the carbonate into the water, or slowly over time all the carbonate will be used up and removed from the water, because it will slowly go into the water and then out of the water. But it does linger in the water for quite a while. You can leave this for 4 or 5 days and it will slowly change its colour. And you can do this. You can bubble it with your own little straw for your water, with your pH indicator in it, and you can watch the pH fall, and you can leave it on a nice sunny windowsill, and it will take 4 or 5 days for that pH to rise up, slowly rising up to become, goes to neutral, and usually slightly over neutral if you've got non-neutral tap waters or things. So I just thought, now, but have you noticed something else here? Not only is it generating carbon dioxide, but it's also generating this nice, I don't know what you want to call this, spearmint green copper carbonate. Now see, the question is this the basic or acidic copper carbonate? Because there are basically 2 basic forms of copper carbonate. There's the alkaline form and there's an acidic form. So that is strange, isn't it? How you can actually get carbon dioxide coming off, but you're also forming a carbonate that is pretty unreactive. So this is where the chemistry gets really interesting around copper, with all these different things. And whoever cracks the copper is probably going to crack the CB conundrum. So anyway, we've done this one here. So this one here has got just carbonic acid, or basically carbon dioxide dissolved in water in this one. Okay, and it's very acidic. Now, one thing I haven't done, which I'm probably going to have to do to show you, is bicarb. We put this one aside. I've done this first of all, I think. Is, if I can get it, is quite alkaline. See that? I don't know if you can see that. So it's quite alkaline. So hang on, I have to put my hand over it. It is quite, 1, 2, 3, 4, quite alkaline. So we're going to put that to one side. So what I'm going to do is make this one up with bicarb. So now, because we know our organism likes to grow in almost neutral water with the reductive flammable gas going through it, which you think would be a nice acidic gas, wouldn't you? But these are all assumptions, of course, and you've really got to go back to the... I need my little thing, don't I? I forgot my little things, so let me just... excuse myself. I can't find it, I think it's in the shed, hang on. Okay, when in doubt, make use of your surroundings. It's not the best. Did I have a pair of scissors around here? Oh, I left those as well. Okay, it's not the best, but it'll have to do, fellas. Have to make do with what you got. Beggars can't be choosers, as they say. Okay, so I'm going to fill this up with the bicarb in the water. I don't know if you want to bring this around here. I suppose what we do have to do is test the pH of the other one to make sure that the polystyrene hasn't altered the pH of the water. So we'll do this. Come on, speed up. I don't know what's gone wrong with the tap pressure here. All the other taps around the house, maybe we've got a leak. Maybe that's it. Okay, so we do this, and we can test the pH of the water here, and then we'll put our 2 organisms in our red one. Yeah, lucky I didn't fill up anymore. And that should be enough, and we'll test the pH of that water. But we also want to test the pH of our other one here. So, right, testing the pH of. We can actually easily just do it on the lid because it's okay. So it's been in there with the polystyrene, with some reductive flammable gas coming through it, and the pH is still quite acidic, as you can probably see. pH of slightly less than 3, I would say. That's why the universal indicator is so powerful and so useful, because if you stick with the old, that's always the best, usually. And there's mucking around with modern stuff. They try and say, always remember Robert Mott's. When those pH indicator kits, they used to sell them so much. Now they're almost like $1 a stick or something. He used to cut them into 3 pieces with a scalpel. I reckon you could do 4, and you could turn $1 into 33 cents or whatever. Or you could turn it into like a 25 cents. In other words, and also you get 4 times as many tests out of the bloody thing. So you get a pack of 50 that probably costs you $50, and you can turn that into 200 tests by using just a sharp scalpel and a bit of a steady hand and a skillful eye, or some combo in between that. Anyway, that's that one. And now we're going to try our bicarb one, just to make sure that the pH hasn't been altered too much initially. Anyway, remember, these are initial conditions. So now we have 2 forms of carbonate there. We got an acidic version with no salt basically there, and we also have an alkaline version, or near neutral to alkaline version, that has some sodium there, and if they don't like salt, will they grow in it or not? But then again, the pH is high, you see. So is it a combination of they don't like acidity and they also don't like salt, our red organism? Anyway, we'll give it a go, and that's probably about as much as I want to do for this set of clips here, I think. And we'll set that up. And I've got a few other things I want to do. I also want to set up one where I do a container here, and not only do I put polystyrene in one of these, I also put some aluminium foil, which slowly over time will degrade and give off reductive flammable gas. So you'll actually increase the amount of, but of course it will also probably form the hydroxide, or maybe even some aluminium carbonate as well, and the pH will change probably quite wildly. But from these experiments, we might be able to work out what our organism is doing or trying to do. What does it like? What does it prefer? What does it love? And go from there. But anyway, that's about it for this set of experiments. I hope you enjoyed the show. But as you can see, chemistry can be quite interesting and very colourful. Remember, colour is your key, I would think. And there's more to copper and copper carbonates than you think. And you might want to explore these things. Okay, over and out for now. See ya.